Imagine looking up at the night sky, knowing that orbiting the very closest star to our sun is a planet that might, just might, harbor alien life. It sounds like a dream, or perhaps the plot of an epic science fiction movie, but this isn't fiction. This is Proxima Centauri b, and it's sending ripples of excitement through the scientific community. Today, we're diving into why this tiny world is such a huge deal in the hunt for life beyond Earth. For decades, scientists have theorized about planets orbiting other stars, known as exoplanets. It wasn't until 1995 that the first exoplanet orbiting a Sun-like star was confirmed. Fast forward to 2016, and a monumental discovery was made right on our cosmic doorstep. Astronomers confirmed the existence of Proxima Centauri b, a planet orbiting Proxima Centauri, which is part of the Alpha Centauri triple star system and, crucially, the closest star to our Sun at just 4.2 light-years away. That's roughly 40 trillion kilometers. Proxima Centauri itself is a red dwarf star, much smaller and cooler than our Sun. It's only about 12% the mass of the Sun and significantly dimmer, emitting far less light and heat. While this might sound like a disadvantage, it means its habitable zone, the region where liquid water could exist on a planet's surface, is much closer to the star. Proxima b orbits its star at a mere 7 million kilometers, 4.3 million miles, which is less than 5% of the Earth-Sun distance. Despite this closeness, because Proxima Centauri is so dim, Proxima b receives roughly 65% of the light energy that Earth receives from the Sun, making its average temperature potentially suitable for liquid water. So, what do we know about Proxima b itself? It's classified as a super-Earth, meaning it's slightly more massive than Earth, with an estimated minimum mass of about 1.07 Earth masses. Its orbital period is incredibly short, just 11.2 Earth days, meaning a year on Proxima b flashes by in less than 2 weeks. One of the biggest questions is whether Proxima b has an atmosphere. Given its close proximity to a red dwarf, it faces intense stellar flares and radiation. Red dwarfs are known for their frequent and powerful flare activity, which could potentially strip away a planet's atmosphere or irradiate its surface. Another fascinating aspect is the likelihood of tidal locking. Because it orbits so close to its star, Proxima b is very likely tidally locked, just like our moon is to Earth. This means one side of the planet would perpetually face star, experiencing eternal daylight and extreme heat, while the other side would be in perpetual darkness and extreme cold. However, scientists theorize that a thick atmosphere could distribute heat around the planet, leading to a terminator zone, a twilight region between the hot and cold sides, where conditions might be more temperate and potentially support liquid water. The presence of liquid water is considered the holy grail in the search for life as we know it. Scientists are using powerful telescopes and developing new instruments to look for signs of water vapor, oxygen, methane, or other biosignatures in Proxima b's atmosphere. However, directly observing the atmosphere of such a small planet orbiting a bright star is incredibly challenging. It's like trying to spot a firefly next to a lighthouse from hundreds of miles away. The advent of next-generation telescopes is crucial for these investigations. The James Webb Space Telescope, JWST, with its incredible infrared capabilities, is already being used to characterize exoplanet atmospheres. Though Proxima b is particularly difficult for it due to the glare from its star. Future telescopes, such as the proposed extremely large telescope Elton Chile, currently under construction, will have mirrors up to 39 meters, 128 feet, in diameter. These giants will be able to directly image exoplanets and analyze their atmospheres with unprecedented detail, potentially providing definitive answers about Proxima b's conditions. One of the major hurdles for life on Proxima b is the extreme activity of its host star. Red dwarfs like Proxima Centauri are prone to frequent and powerful stellar flares, which are sudden bursts of radiation that are far more intense, relative to the star's total output, than those from our Sun. A 2021 study observed a superflare from Proxima Centauri that was 100 times more powerful than any flare ever observed from our Sun. Such events could repeatedly sterilize a planet's surface or erode its atmosphere over billions of years, making the emergence and sustenance of life incredibly difficult. Despite the harsh surface conditions, some scientists hypothesize that life on Proxima b might exist subsurface. If the planet has a geological activity or subsurface oceans, life could thrive in environments shielded from the harsh stellar radiation. Similar scenarios are considered for moons in our own solar system, like Europa, Jupiter, or Enceladus, Saturn, which are thought to harbor subsurface oceans beneath icy shells, potentially warmed by tidal forces. Even if we detect gases like oxygen or methane in Proxima b's atmosphere, it doesn't automatically mean life. These biosignatures can also be produced by non-biological geological or chemical processes. Scientists would need multiple lines of evidence and a deep understanding of the planet's unique environment to confidently claim the presence of life. It's a complex puzzle, requiring careful analysis to avoid false positives and ensure any claims of life are robustly supported by data. It's crucial to clarify that NASA, nor any other space agency, has confirmed the existence of life on Proxima Centauri b. While it remains a highly exciting and promising target for astrobiological research, all current evidence only suggests its potential for habitability, not the actual presence of life. The search continues, and every new observation brings us closer to understanding whether our nearest exoplanet neighbor is truly a haven for life. The excitement is real, but the definitive confirmation of alien life is still a goal for the future. Proxima Centauri b stands as a testament to the incredible diversity of planets in our galaxy and the persistent human drive to find life beyond Earth. It challenges our assumptions about what makes a planet habitable and pushes the limits of our observational capabilities. While the internet might get abuzz with rumors, the scientific process is slow, meticulous, and requires irrefutable evidence. Today, we truly confirm life on another world will be one of humanity's greatest milestones. And Proxima b is certainly a foutrone in that historic race. Thank you for joining us on this cosmic exploration.